Alright, hi folks, today I'm back with another kind of random video, but I just want to give you guys a progress update on my project that I started at school. And so this is the triangular voltage generator that you saw in the previous video. I just kind of want to give you guys a demonstration of what the final product looks like. This blue tape is not part of the design, but it's to protect the identity of my partner. So on the back there's a switch here, the very nice tactile switch, just like the JDS Labs C5 portable headphone amplifier. Then on the front we have a headphone jack to measure or hear the output signal of this triangular voltage generator. Then in the middle here we have the frequency change, and then to the right of it we have the triangular wave symmetry adjuster. And so by adjusting these potentiometers you can adjust the symmetry of the triangular wave, as you saw in my previous video. And so let's get this hooked up. I have a speaker right here, and just plug in your 3.5mm headphone jack into the port and turn up the volume, and you can hear that annoying sound. And so we can change the frequency . So this is just a standard potentiometer screwdriver. Has a little notch there for the potentiometer to go on, and yep, you just adjust those knobs. And so I guess I can change the triangular wave symmetry just to give you guys an idea of what this sounds like. And so if you can hear the signal right now, it sounds pretty flat. Then if you adjust the symmetry, I'm not sure if you guys can hear that, but it kind of sounds like a resonance effect where it becomes a little bit louder and more annoying to listen to. Yep, just like that. And anyway, that's what that kind of sounds like. You guys are probably bored by now, but I wanted to give you guys an idea of what this looks like on the inside. And so this actually runs on two 9-volt batteries. And this switch was not part of the design originally, so we kind of had to squish everything inside this box. And if you guys couldn't tell by now, this box is actually the same box as the Objective 2 headphone amplifier. This was purchased from JDS Labs. I think it was around $15, so it's not too bad. And this front plate was actually laser engraved by JDS Labs as well, so I want to give them a quick thank you for the laser engraving. They did a really nice job of it. And like I said, this switch was not part of the design, so we actually drilled the hole for this this switch by hand using a drill press. So that was an interesting experience. Haven't really used a drill press before, so that was kind of cool. And this is one of the projects where I wanted to kind of demonstrate that you don't have to be an expert in the audio field just to build cool devices. This was actually an extra credit school assignment, and everything was kind of thought of by me with the output audio and whatnot. But you don't have to be an expert to do this kind of stuff. And if you guys didn't know by my profile page, I'm trying to major in bioengineering, so I'm not an electrical engineer or anything. So anyway, here's the back of my device. Let's get autofocus there. So there's the two 9-volt batteries. Can go ahead and slide out this panel and put some blue tape over my partner's name again. Alright, so this is the PCB board that we built, and the company we used to get this board manufactured is from OSH Parks, and so I'll put a link in the description below. But basically what you do is that you make a circuit board diagram in the program. The program that I use was Eagle CAD, or CAD Soft Eagle, but you can use any program you want, and then you upload the board file to their website, and then they will manufacture the board for you. So taking these batteries out, here's a up close look at the board. So just like in professional electronics, this is a PCB board, and so there's no wires that are exposed to connect the different components. They're built inside of the board. So as you can see, there's op amps here and here, and one of them does the integration of the signal, and the other one does the I don't really remember the schematic off the top of my head, but one of them does the integration, and then you measure the output of that. I believe it's this op amp, and then this one does the other thing for the amplifier. Again, sorry, I don't have the schematic in front of me, so I don't quite remember what these two op amps do. But here's the headphone jack, and my circuit right now only has a mono sound, so there's only one output of the circuit connected to the left jack of the headphone port, but I have two output ports, so I could technically make it a stereo sound. So here are the adjustable potentiometers. Right, here's the main frequency one, and then you have the two symmetry ones. And then here are the wires for all of the power management. So on this side we have one battery. Then on this side we have a switch connected in series to a battery. And so when you turn the switch on or off, it allows the power to flow through from the battery to the rest of the circuit here. But yep, that's the board overall. The bottom is all ground layer, so it's kind of a darker purple color if you can't tell in the video. And everything here is soldered with the soldering iron and silver solder. So that's what our project is. Thanks for watching. If you have any questions or would like the schematic for it, I actually do have it, so I can send you a link to that if you're curious. But other than that, happy Memorial Day for those of you who celebrate it in America. Otherwise, thanks for watching, and have a good day.